Hello, everyone. We're just giving it a few minutes for, everyone to join. I'm going to give it a few more minutes, please. We're still seeing a lot of folks join. So we will get started right at 10:05 Pacific time. So which is 2 more minutes. Okay. So I think let's probably get started with something small. So welcome everyone. Welcome to Beginner's Guide to CI/CD. We're going to get started in few minutes. We're going to give it a couple of minutes for others to join. So in the meantime, could you all please let us know in the chat where you're joining from today, your name if you want to, and what the weather feels like today. So let me post. Oh, wow. Hi, Gauri from India, and it's raining. Hamsa from Seattle. Oh, wow. Yes, I'm from Seattle as well. And yes, it's a surprisingly sunny day. Yeah, so when you send a message, if you could actually click send to everyone, the message will be displayed to everyone. So please ensure you're not sending it to just the host and the panelists, but you're trying to send it to everyone. Oh, hi, Nidhi. Again, it's raining in India. That's amazing. Okay, cool. I see a lot of folks have joined, and let's get started. So I'd like to welcome our speaker for today, Hamsa, and she's going to be presenting a beginner's guide to CI/CD. What is our mission? Empower diverse women to excel in technology careers. That's what Women Who Code is, and that's what we do. Our vision is to create a tech industry where diverse women, are getting included and also get equal opportunities to grow up their ladder. We really followed our code of conduct. We are very serious about it, and we want to create this inclusive community where everyone is given an opportunity to empower themselves and also empower others in the process. And we have a lot of events that are intended to inspire women to excel in technology careers, and anyone who is there for this purpose is welcome. So yeah, we welcome you all. And our upcoming events, we have 2 events that are scheduled for now. So one is on the 23rd September about the cloud security, minimum security baseline. And then we have the Connect Latin American event on October 13th, Thursday. We really encourage all of you to sign up for all the events. And yes, we'd love to, have you all stay connected with us. So please join Women Who Code Cloud on our Slack channel. And also you could find us on LinkedIn, Twitter, Instagram, and Facebook with the @wwcodecloud hashtag. So now, yeah, our speaker today, Hamsalekha Venkatesh, she's a software engineer here in the Seattle area, and she's going to be presenting a beginner's guide to CI/CD. I'd now like to hand it over to Hamsa to take it forward.
Awesome. Hi. Can you guys hear me now?
Yes, Hamsa.
Awesome. Thank you so much for the warm welcome, Rashmi. I will go ahead and share my screen. So can you all see my screen?
Yes, you're great.
Awesome. So thank you everyone for gathering today. I know sometimes getting up on a Saturday morning and attending a presentation is something that will be really tiring. So I really appreciate you all being here. So without much delay, let's get started with the presentation. So a little bit about myself. My name is Hamsa. I'm from the Seattle, Washington area. I was the senior software engineer at Redfin. So that's where I got an opportunity to work on DevOps and CI/CD related technologies. So a lot of my talk, I'm going to be sharing the lessons, the mistakes, the challenges that we faced when we migrated to CI/CD at Redfin. And I will soon be joining Spotify as a backend engineer. Apart from my career, I love baking. I like trying new recipes, and pandemic was a time where I started my own little bit of IG channel. So if you're interested in baking, like you can just check out my Instagram channel as well. And I love biking and hiking. So if you know any interesting spots in Seattle, like do hit me up. I would love to connect with you about CI/CD, hiking, and all the other interesting activities that we can chat about it after the presentation. So let's get into the meat of today's topic. So today's agenda, I want to cover about, first I want to introduce you all to how a traditional monolithic deployment takes place usually, right? Like, so this is something that I want to draw from the previous experiences in my company, like how a traditional monolithic deployment takes place. What are some of the challenges that we face when we follow a traditional monolithic deployment? Why do we even care about CI/CD? What are some of the benefits that we could reap from using the CI/CD in order to deploy our applications? And a majority of the time today, I want to focus on GitLab. So GitLab offers a variety of features for us. But for today, I'm going to focus only on the CI/CD portion of the GitLab. And I want to set the stage by introducing some of the terminologies associated with GitLab CI/CD so that we can be comfortable in designing our own pipeline. And in the part 2, I'm planning to give a small demo of the pipeline using the GitLab CI/CD. So this is the agenda. So without much delay, let's jump into the presentation for now. Okay, so let's first try to understand how a traditional monolithic deployment takes place, right? So let's start from left to right here. So we have a huge monolithic code base here. So to understand things deeper, I want to take an example of a shopping cart like Amazon or eBay, like an e-commerce website, right? Like, so when I say it's a monolithic code base, we have several different teams working on an e-commerce website, right? You have teams working on notifications, you have teams working on payment, Android, iOS, checkout, billing. All these teams, they actually share a single code base repository. That's what I'm referring to as monolithic code base. So you have different repositories, and every development teams, they share a single code base. So traditionally, how the deployment usually happens is, it's like all teams, they deploy at one go, or it's none. So it's like all or nothing deployment. So because all the teams, they have to coordinate with their releases, usually the teams, they agree upon a particular time of the day where you want the deployment to take place, right? So let's say that at evening 6 p.m, when everybody is done with their deployment, you basically decide, okay, that's where I'm going to have a kind of like a mini code freeze, where I'm going to push whatever code change all the development teams has done to the main branch, to the production. So what you do is, you have some sort of a nightly automation. It could be like a cron job that runs every day at 6 or 6:30 in the evening. And then what the cron job essentially does is, it's going to cut off a release branch from the main branch. So usually there is this person, like a release owner, who coordinates the releases between the team. So he or she will basically decide the release number. So depending on whether you want to bump up the major, the minor, or the patch, you decide, you come up with the release number, and whatever code change all the development team has done on that particular day, you deploy it into a huge VM instance, right? Like, say for example, if I am deploying it on AWS, probably you can deploy it onto a huge EC2 instance, where you build the code base. And then once the build has done, you enter into the test stage. So one thing that I want to call out here is, because this is a monolithic code base, it should come as no surprise for us that there could be like several 10,000s and thousands of test cases in the monolithic code base, right? So realistically, especially when you're running this deployment every single day, it is not possible for us to have all the 10,000s of test cases passing. So what we did in my previous company was, we gave this as a flexibility to the development teams. We trusted our development and engineering teams that they would have tested all these functionalities in their local. And even if all the test cases doesn't pass us, it's okay. There could be a lot of flaky test cases, and we don't want that to be the blocker for you to ship the code to the production. So what we did was, once your build stage is done, you can optionally skip the test cases. You don't have to wait for the test cases to complete successfully. And then depending on how your application is configured, you can package it. Probably you can convert it into a jar or a war file, or if you're trying to dockerize your application, you can containerize it, and you can give an appropriate version tag for the container. And then you publish it to some sort of a repository, like it could be like Artifactory, or it could be like a Docker hub, depending on how you have configured it. And then once you have completed this part of the pipeline, you can have the deployment servers polling from the respective jar or the Docker image, and you can start the deployment process. So if I'm working for, let's say, like a shopping cart team, hopefully after a couple of hours of following this traditional deployment, finally my product now reaches the customer. So this is how, at a high level, before the invent of CI/CD, a traditional deployment strategy takes place. Now, the real question is, were we really happy with the way the traditional deployment takes place? Meaning, like, what are some of the challenges that we encountered during this process? As you might have observed, the first biggest pain point for us to even start thinking about CI/CD is slow deployments. Especially for a big company like Amazon, right? Like Amazon or eBay, having just one deployment per day is not something that we would want to do. Like, it's a healthy problem to have a lot of deployments done in a day, so that you can ship your features faster to the customer. But without CI/CD, especially when you follow a traditional deployment strategy like the one we just saw slide back, you just do one deployment per day. And let's say, for example, if the notification team, if they have any bug in their code, you will be forced to roll back the entire release. So even if I belong to, let's say, like a checkout team, just because if notifications team has a huge bug, I will be forced to roll back my release. This is the first biggest pain point that we started seeing, which led us think about adopting a CI/CD culture within the team. The second is flaky test cases. One thing that I learned through my time, through my engineering career is, the sooner you run test cases and catch the bugs at earlier stages in your pipeline, you will be able to have, you'll be able to make a fix which is less expensive. So here, because you run it as a monolithic code base, you can't realistically expect all the 10,000 or 20,000 test cases to pass even after 3-4 attempts. So you would have seen me mentioning that we gave the test stage as an optional one, which is something we did out of a choice because it's a monolithic code base and we want the deployment to take place. The third biggest pain point is the complex code base. What I mean by complex code base is, let's say that if I am a new developer joining into a particular team whose code base is in monolith, it's going to be really difficult for me to understand the code base because everything is tangled. I will not be able to do a smooth development in my local. This is actually one of the real challenges that we faced in my previous company, especially when we were working on a front-end team where we had to download the entire clone the entire monolithic code base in the local, and just to do a local development we had to build the entire monolithic code base, which took a lot of time for us to build. So the complex code base is something which we want to avoid and make it small and lightweight so that you can do frequent deployments. The fourth challenge that we faced is scaling. What I mean by that, so let's take the example where you have some Thanksgiving or like a Black Friday deal where you just want to selectively scale only the notifications team, right? Do you think with this particular monolithic deployment, we would be able to scale just one team? Realistically, it's not possible. There are a lot of impediments that we would face. So you will end up scaling either all the development team's resources, or you will end up scaling none. So the biggest challenge is you end up wasting a lot of on-prem or cloud resources. So individually scaling according to the team needs is not possible, especially when you are logged in a monolithic code base. Last but not the least is a very slow feedback loop. Let's say that today, if I create a new feature, say like a shopping cart, if I add a new functionality to a shopping cart feature, the code reaches the production only after, like, say, like by tomorrow, or hopefully if the entire night, the nightly deployment finishes successfully, which means that I will not remember the code. The code won't be there fresh in my mind. And as a result, I will have very slow feedback loop. Like maybe after a day or two, I will realize that, okay, this code has caused some bug in the production and it's a high time that I have to make a 7-1 fix and try to fix the code. That is something which we want to avoid, right? Like the code, if I'm making a fix for a particular code today, the code is going to be fresh in my mind today. And if there is any bug, I would want to fix it as quickly as possible and not wait for a couple of days for the bug to actually be detected. The last but not the least is, this is one of the favorite memes, and I'm pretty sure every one of you here would have faced this issue at some point in your career, where you know that a particular code, it works fine in local, but there are high chances that it breaks itself in production or pre-prod environment. This is one of the important motivation for us to move to container related technologies, so that you can try to replicate your local environment as close to the production as possible, so that you are confidently able to ship features to the higher environments. So because of all these pain points, this was the serious motivation for us to move to CI/CD practice. So with this in mind, I will officially introduce you all to the definition of CI/CD. So CI, it stands for continuous integration, and CD, it stands for continuous delivery or continuous deployment. The idea behind CI/CD is, how can you automate all these software development workflows that we just saw, right, like a couple of slides back, where for every code commit that you want to make, whether you want to build, whether you want to test, you want to package, you want to apply any governance, how can you automate all these process? That is the real idea behind CI/CD. So why do we care about automation? Because automation, it reduces a lot of errors. You don't want to manually keep doing these repetitive things again and again. You want to let the machine do its work for you, so that as a human, we can spend our time and our intelligence in solving real problem, instead of just worrying about automating the software development workflow. So that is the real problem CI/CD will help us solve it for us. So some of the popular CI/CD options available in the market are this. So it could be a little overwhelming to actually pick, especially if you're starting it from scratch. I would just recommend you to pick any of the famous vendors like Jenkins or GitLab or GitHub or any of these, because you cannot go wrong, especially if you're starting at the beginning. But for today's topic, I'm going to be focusing on GitLab. I have a reason why I've chose GitLab in the next slide. So moving forward, I will try to use a lot of GitLab specific terminologies, so that we can get started with understanding the GitLab CI. I see there is somebody is asking, is the audio working? I hope you all can hear me. Okay, awesome. Thank you, Stephanie. Yeah. Okay. Okay. Now let's try to understand why GitLab, or what are some of the advantages we can get out of GitLab. So the first is an all-in-one ecosystem. What I mean by that, so GitLab is one of the tools where you can say you can use it as a code repository like SCM to save the code base, and you can also have CI and CD options, all three in one ecosystem. So in real time, especially when you're working on a complex project, you would ideally not just involve the development teams, but you will also involve the infrastructure team, which is a DevOps team, to help you set up the infrastructure for the pipeline. And you will also involve security, the product, and various different teams will collaborate in order to solve the problem. So GitLab has several different tools that caters to different teams within the company, so that everybody can just work on one particular project without having to worry about switching to different teams. That's one of the biggest power, or the true power of using GitLab. The second is it's cloud agnostic. So what I mean by that is, let's say that if your team suddenly, if they decide to move to GitLab in order to adopt a CI/CD practice, and if you're already on a cloud vendor, say like Azure or GCP or AWS, you don't have to worry about migrating all your existing cloud infrastructure to GitLab. GitLab has native support for a lot of different cloud providers. So it's going to be a relatively seamless and smooth transition for you to start adopting to GitLab CI/CD without worrying about the other infrastructure related hassle. The third is GitLab supports two kinds of two flavors of hosting. One is an on-prem and another is a SaaS. So what I mean by on-prem is, it is up to the company or the team to basically host and manage the GitLab server. Why do you want to choose on-premise? Say, for example, if your team is working on a very confidential, or if security is something very important for you, where you don't want some third party to manage your data, in that case, you can prefer on-prem flavor of GitLab, where you take the responsibility of maintaining, hosting, patching the vulnerabilities. So this has a drawback where you have to take care of patching. Otherwise, you will end up having some vulnerabilities if your servers are not up to date. The alternative to that is called SaaS instance, where you let GitLab itself GitLab manage and host the server for you. And as a company, you focus on solving the complex business problem that is in hand. So probably if you're like a startup or any small scale company, you can adopt a SaaS-based instance where you can just focus on using the GitLab as a service, and you can delegate the responsibility of maintaining and hosting all these servers to GitLab. The fourth is another powerful advantage which GitLab offers. It offers built-in governance and capabilities. So like I said, since a lot of different companies, they are migrating to cloud, it becomes very important for every company to adhere to a lot of industry related complaints like SOX or CCPA for privacy, HIPAA, CRPA, and all these. So ideally what you can do is you can harden all these security related governance policy as a part of your pipeline. So for every code commit that every developer makes within the team, you can verify and validate if it's meeting all these governance related policies, so that you will be able to confidently push the valid code to your customers. Last but not the least is a growing community. So GitLab has been there and it's been there for several years now, and its community is constantly growing, and a lot of different people are using GitLab, and the product is also quite matured enough. So the thing what I'm trying to say here is you're not alone if you face an issue. They have excellent documentation, and and whatever issue that you face, somewhere some other company or engineers would have already faced those issues, and you will be able to reach out to the community for help and support, which is a true part of using GitLab as a CI/CD solution for us here. So these are some of the well-known customers of GitLab, just to highlight how mature the product is. So now, if we were to convert this CI/CD, the monolithic deployment into a GitLab-based one, this is how the pipeline would look like. I just want to call out here that this particular standard template is not specific to GitLab. It's even if you adopt any CI/CD practice with GitHub or any of the other vendors, the pipeline idea would remain the same. But this is how you will try to move your application out of the monolithic code base and start thinking about CI/CD approach. So let's take the example of a shopping cart. So now the idea here is you would have moved the shopping cart out of the monolithic code base, and you will you will isolate it into its own repository. So say for example, if you have some developer who's trying to create a new feature branch from the main branch, let's say that I create a new feature branch and I have tested the code in my local, and I've made sure that all the functionality and the unit tests, everything is working fine. The moment I check in the commit into my branch, I can trigger the CI process. So you can configure GitLab to automatically trigger a pipeline for every commit the developer makes, which is really amazing, because you don't have to wait till the end of the day for your code to actually go to higher environments. So the first step that you ideally do is you build the code base depending on what kind of code base, whether it's a Java or a Python or a Ruby code base, and then you test it. So say for example, if in the local I forgot to catch some bugs when it comes to unit testing, I will know that I will know this when I'm running the pipeline. I can probably make the code fix and re-trigger the entire pipeline. And let's say that I'm trying to Dockerize this application so that I can deploy it into Kubernetes or any of the container orchestrated technologies. So the next step would be for me to package this application into a Docker container, and then I can apply some sort of a compliance rule. So say for example, if I have to do any sort of container scanning or image scanning, I can have that as a separate stage. So the idea is if any one of these stages fails, then you can immediately fail the entire pipeline, meaning that your code will not even get deployed to any of the development or test or any of the environments. That's the real power of GitLab, because all these stages will run in sequence. Just bear with me here. I will introduce you to the stages, to the different terminologies in the next couple of slides. But try to understand, like, this is how the pipeline would look like. So after you have run a series of checks on the image and container, you can publish this to any of the repository like Docker Hub, or it could be like Artifactory. And then once you have published it to the respective environment, you can enable the merge button on the PR. So the merge button would be enabled only after all these checks have passed. So say for example, if you are submitting the PR for code review, your peers, they don't have to worry about whether the unit tests have passed, whether the container scanning is passed, whether your application code is secured or not, because all these things would now be delegated to GitLab. As a code reviewer, your responsibility is just to verify if the business logic is fine, if the code requirements are met. And after that, I can approve the PR. The peers can approve the PR. And after you have got the desired number of approval, you can merge the PR into the main branch. Right? After the merge is done, you can automatically configure your GitLab pipeline to trigger the deployment. So I can either deploy it into a server, on-prem server, or I can deploy it to any of the Kubernetes using Spinnaker or Argo CD. And finally, once the deployment passes, I can promote this build to higher environments. And within about like an hour or so, my code would be available in production. Gone are those days where I have to wait for the release owner to decide what version, and then wait for the nightly job to complete, and be unreliable whether the unit test cases would pass or not. This is how simplistic the CI/CD pipeline would look like if you, a deployment pipeline would look like if you adopt a CI/CD practice. So the main advantage of using this is you have an extremely fast feedback loop. Let's go through some of the advantages of, yeah, okay. I think I just jumped a slide over here a bit. I want to talk about some of the challenges that we faced in my previous company when we actually started adopting to the CI/CD approach. So because we had a lot of different teams whose code base was in monolith, identifying the teams or the candidates to pick out so that they can move their code base out of the monolith was a big challenge. So initially we tried to identify the independent teams, but as and when more and more teams started showing interest to move their code base out of the monolith, let's say if team A is dependent, is like tightly coupled with team B, there was a challenge for us to identify whether to move both A and B together, or how do we move about the teams with. So figuring out that dependency was quite tricky, and we had to figure out a way to come out of that. The second challenge that we faced was knowledge transfer. So a lot of development teams, when we decided to adopt to Kubernetes for deployment in my previous company, they were not that much familiar with the Kubernetes command. Like as a development teams, it's not fair for everyone to know their Kubernetes command. So as a result, it became the responsibility of the DevOps team to help them debug their application, help them understand how to debug their application, especially if it fails for any infrastructure related technology. The third challenge that we faced was having an updated documentation. So as we started growing, more and more teams wanted to use the CI/CD pipeline which we were designing. There was we only had very limited resources available. So which means that we had to constantly update our documentation in order to welcome the other teams to contribute to our libraries and workflows. So that is another challenge that we faced, and that's when I truly understood the importance of having a good documentation, because even if a developer is leaving has left the team, it'll be easy for other developers to pick from where he or she has left. The fourth is diversity of the teams. So initially, we actually designed the pipeline which catered towards Java, because a lot of development teams actually use Java and they build their code base using Maven and Gradle. But as more and more teams like machine learning and other front-end teams which used a different code base like Python or Node, they started onboarding themselves to the pipeline. It became little difficult for us to start adding a lot of different workflows which caters to different teams. So we had to prioritize based on which is important, so that we can focus on majority of our audience. That was another healthy challenge or healthy problem that we faced. And earlier, initially at Redfin, we actually used Jenkins and Bitbucket. So even after performance tuning, as more and more teams were getting onboarded, the Jenkins, it could not take a load even after vertically scaling a lot of the resources. So as a result, this was one of the main reasons why we wanted to explore the other CI/CD vendors like GitLab and GitHub. And that actually led to us doing a lot of POC in order to figure out which CI/CD vendors would be an ideal fit in order to meet the growing demands of the team. So some of the benefits of adopting to the CI/CD is we have a faster feedback loop, which means that whatever code change I make, I don't have to wait till the end of the day to make it go to production. I'm able to get a faster feedback loop, and even if there is a bug, I'm able to quickly fix it, and so that the customers are quite happy. You can automate a lot of different workflows. You can automate testing, which is very, very important, because you don't want to keep running all these test cases manually. You want to automate a lot of things so that you catch bugs quickly, and you make sure that your code is well tested before it goes to production. code is production ready. So what I mean by that is you are trying to keep your local development as close to production as possible. So whatever code is there in your local, you ship it fast to your production so that you're able to constantly get a feedback about your code, and you're able to make constant improvements to it. Automated deployments was another important benefit that we started getting out of it. So your CI will automatically trigger a CD. So every time you check in a code, you are guaranteed that if your deployment succeeds, it's going to be there for you in all the environments that you have configured. And hardening the security and compliance is a huge plus point that we started getting out, because we want to make sure that our code is does not have any vulnerabilities, be it like CVE vulnerabilities, or it could be like any linting errors, and all these things we can test it, because these are all repetitive tasks which you don't want to have a human to test it. So you can automate a lot of different things, and automation was the real power that we started seeing upon using GitLab CI/CD. So with this thing in mind, let's go one level deeper and try to understand some of the GitLab specific terminologies. So what I'm planning to do in the next couple of slides is, in order for us to start using the GitLab CI/CD functionalities, I want to set the stage for some terminologies so that we can better understand them before like starting to use those. So this is the block diagram that I want you all to just keep in mind. This is available in all the slides for us. So with this, I'm going to explain every single terminology here, so that we can, by the end of next 15-20 minutes, we will be able to write our own GitLab CI YAML file that will help us to construct a small pipeline of our own. So the first terminology that I want to introduce you all is a pipeline. So this entire step is called as a pipeline. So that's the top level component that you basically run. So the idea is, for every commit that the developer makes, you trigger a pipeline. So a pipeline is nothing but a collection of different stages within your CI/CD. So even if any one of the stage fails, your entire pipeline is going to fail. So if your pipeline fails, you're not going to push any deployment to any of the environment. That is the meaning of a pipeline. The second terminology is called a stage. So a stage is nothing but a different. So basically, like your pipeline is made up of several different stages. The idea behind the stages, it does one functionality, but it does it just does one functionality together. So let's take this example over here. You have a test stage. So in the test stage, you only do testing, but you can do different kinds of testing. Say, for example, you can have unit test, you can have lint test, you can have probably like a DB test. So all these different jobs within a particular stage would run in parallel, and the stages would run in sequence. So if your prepare stage fails, your build, your test, post test, everything will not be executed. They all get executed in serial. That is the idea of a stage. These are some of the different states in which your stages can be. So the first is, if you see this backslash, that indicates that your stage has been cancelled. Either it can be because you manually canceled that particular stage, or GitLab has cancelled it for some reason. The exclamatory mark, it indicates that your stages has completed, but with a warning. So the beauty of GitLab is, for every stage, you can clearly see logs associated with it. So you will know why that stage has failed, or what is the warning associated with that particular stage. And then you have this green tick mark, which indicates your stage is successfully completed. The blue circle, it indicates that your stage is currently running. It's the stage that GitLab is currently executing. And the gray dot, the gray circle, it indicates that your stages are being prepared, meaning that it's waiting for its previous stage to start to complete it, so that this can start. So it's waiting for the ancestor to complete so that it can basically start. That's the idea. And then the red cross mark, it indicates that your stages have failed. Probably it could be any reason, and as a result, your entire pipeline has has failed. And the double right arrow, it indicates that your stages have been skipped. So it could be because you might have added some conditions to your stage, saying that, okay, I want this stage to be executed only in certain environments. I don't want it to execute. So maybe GitLab might have skipped those stages and it might have moved forward. So that's the idea behind the stage. The third terminology is a job. So a job is nothing but a sequence of steps within a particular stage. So like I said, a stage does one thing, but every instruction within a stage is called as a job. The idea is your jobs will always run in parallel. So which means you should not have any dependencies between the jobs. So if you take, for example, this test stage, right, it has a colon, a slash, and a space test. We should not have any dependencies between these jobs. There are like two kinds of jobs here. You have a manual job and you have an automatic job. As the name says, a manual job is something that you can manually trigger it. For automatic jobs, you can have cron expressions so that at certain intervals of time, these jobs will run, and you'll be able to execute them. One thing is that you'll have to keep in mind is your jobs, they can or cannot produce an output. So that output is called as an artifact. I will talk about artifact in the next couple of slides. But one thing to remember is the jobs, they have a log. So every step will clearly tell you what instruction GitLab is running, and other details that will help you to identify. Suppose if your job has failed, you will be able to quickly debug why your job has failed, whether is there any warning associated with it, what instruction it's executing. Everything you can, it's super transparent when you're using GitLab. The fourth terminology is artifact. Artifacts are quite important ones. The reason is because your stages, like I said, they are independent of one another. So you can't. So if you take a particular stage, it runs in one particular VM kind of an instance. So if you want the output of one particular stage to be passed as an input to another, you pass it as an artifact, right? So your artifact is nothing but like an output. So it could be like your jar file, it could be like your zip or your Docker image or your WAR file that you produce as a result of a particular stage is called as an artifact. So there are like two kinds of artifact here. You have a job artifact and you have a pipeline artifact. A job artifact is nothing but the output of a job. So if you take this example over here, you have a job. If your individual job, if it produces an artifact, that is called as a job artifact. Whereas at the end of the pipeline, if you produce an artifact and that gets pushed to any of the repositories like Docker Hub or Artifactory, that becomes a pipeline artifact. So if you take, this is a snippet that I took from GitLab CI YAML file. So this is a job. So if you see over here, the name of the job is called create superhero job, and you have a script which is called as a dccomics.js. This script is what is going to create this artifact for this. So if you want to define your artifact, you have to use the keyword artifacts, and you are specifying where this artifact has to be saved. So I'm saying you save it in the current directory because I've not given any path. It's going to save it in the current directory, and wonderwoman.pdf is the name of the artifact which this DC Comics is going to create for us. And optionally, you can give an expiry. So here I'm saying the expiry is 1 week, which means I'm telling GitLab, hey, you recycle this job after a week. So the thing is, all these, it could be a little overwhelming, but GitLab has excellent documentation, and I've actually added the notes. I've linked the respective document in the notes section. So please do take a look at that, so that these terminologies will become quite, you'll become quite familiar with these terminologies in case if it's quite new to you. The last but not the least one is the variables. So variables are quite similar to variables in any object-oriented language. So they are basically like placeholders. So you can actually have, they hold a value so that you don't have to keep repeating all these values over and over again in your GitLab YAML file. So if you see here, the image name is the variable name, and this is the value that it takes. I can use the $sign followed by the variable name in order to reference that particular variable. So just like how you have global variables and local variables in any object-oriented programming, you have similar variables here as well. So the idea is, if you define a variable on top of a job, it becomes a local variable and you can only use it within that particular job. But if you define this variable at the very top of your GitLab CI YAML file, which I will explain it to you in 1 or 2 slides, that becomes like a global variable, meaning that you can access the variables anywhere in your YAML file. So GitLab, it offers 2 kinds of variable. One is a user-defined variables, and another is a predefined variable. So the user-defined, okay, I just jumped ahead. Yeah, the user-defined variable is nothing but these names that I define in just to make my GitLab CI YAML more readable is called user-defined variables. And apart from that, your GitLab itself offers a bunch of predefined variables. So, say for example, if you when you are running the pipeline, you want to know like who's the author of the particular pipeline, or you want to know which environment your code is being deployed to, you can leverage these predefined variables so that you can dynamically determine its value and make decisions. So say for example, if you're trying to run certain jobs only in production environment, you don't want it to run in other lower environments, you can leverage these variables and you can add conditions to your YAML file so that you execute that job only in those environments. They come in very handy, especially when you're designing a complex pipeline where you want to make decisions based on certain environments or certain keyword pipeline specific decisions. The last is the environment. So the environment will tell you where you want to deploy the particular code to. So say for example, if I want to deploy the environment to release or production or staging, that is called as a static environment. So it's called static because you know the names of the environment ahead. There are like dynamic environments as well. So when I say it's dynamic, you determine the name of the environment dynamically by using these variables. So usually every environment will have a name and it will have a URL. So if I say staging.example.com, it means I'm going to deploy that code to this particular internal staging environment or internal production environment accordingly. So that's the environment. That's the concept behind the environments here. And the last one is called runner. So the runner is very important because your runners will define you the VMware, or it provides you the compute instance where actually your code runs. So one important thing that we'll have to keep in mind is GitLab, it offers Docker, it offers native container support for running your pipeline. So which means if you want to specify your runner, you specify it as a Docker image. So say for example, if I have a Java code base and I want to run my application, I have to specify an image which has Java, and say if I'm using Maven or Gradle to build, I need to pick the respective image so that that particular job, it runs in that runner which has Java installed. Otherwise your app is going to fail. If you don't specify any runner, by default, GitLab is going to generate you a Ruby runner. So if you are trying to run a Python or a Java application, it will fail and you will have to specify the runner, correct runner appropriately. So if you see this example over here, right, you have the unit test is the name of a job. There is an image associated with it. I'm saying like I'm saying you take the Python image because I'm trying to run a Python code, and I'm saying that like this is going to be a say I'll pick an image which has PyTest associated with it. I'll be able to run GitLab will automatically generate a Docker container with this image for me, and it will run the code. And then after that, the runner will automatically be shut down by GitLab, and you automatically, suppose if it produces any artifacts, that's going to be persisted in any of the artifactory. There is another concept called autoscale runner, where depending on the load, GitLab will provision you the appropriate runner. Say suddenly if I'm having a lot of spike in my traffic, say for notification scheme, if it's having a lot of notifications, you can spin up the appropriate runners depending on the workload. It is very similar to auto scaling groups in AWS or other cloud providers. This is an important point because you all these runners you will have to, they have underlying support for Docker containers. So with that, I have covered the important terminologies for all the GitLab. So just to recap whatever we have learned, you have a pipeline, which is the top level component. A pipeline is made up of a collection of stages. Your stages will run in sequence. Every stage will have a job. All these jobs will run inside a runner, and your jobs will run in parallel. So if any of the job fail, your stage is going to fail, and the stage failure is going to impact your pipeline failure. And then you have artifacts. There are like two kinds of artifacts that we learned today. You have a pipeline artifact and you have a job artifacts that gets pushed to the repository, either at the end of the pipeline or at the end of a job. The stages are independent of one another. That's why we depend on artifact. So say for example, if you are generating an artifact for build and you want it to be used in your promote stage, you can pass this through the artifact repository over here. And then you have environments, which will tell you the layers at which you want to test your code before it goes to the production or internal production environment. And then you have variables, which I have not written it over here, but they are basically like placeholders that will help you to write and define your own YAML file. So with that in mind, we are ready to actually write our own pipeline here. So if you want to define your own GitLab CI/CD pipeline, you need to have a file called .gitlab-ci.yaml. This format, the name of the file has to be like this. It has to be with YML, and it has to start with .gitlab-ci, because that's when your GitLab will pick that particular file, and it will be able to know, okay, I have to watch this repository for a particular code base. So this has to be at the root level, and you will be defining the different stages, and you'll be defining the different jobs that you want to run for every particular pipeline. And you have tons of other features which I have not covered here because of the time constraint. So that will help you to configure your own pipeline. So this is the last slide. So I just want to give you a real world example of how a CI/CD pipeline would look like. So moving back to my shopping cart example, if it were a Java application built using Maven, and I want to Dockerize and deploy this application on Kubernetes, this is how my pipeline would look like. So the stage 0 would look like cleaning the dependencies and cleaning the slate. And then I have building, which is Maven compile. I have a stage 2 for testing, which is a Maven compile test. And then I can Dockerize this application. And then I would be tagging that particular image. And then I can push it to Artifactory. And then once in the development environment, if the deployment passes, you can promote the build to higher environments. And finally, in the production, I can validate and I can verify whether the changes are working fine. So this is how a typical stage would look like. So you can write it as a shell command, or you can give it as a Docker commands in your job, so that every command it will get executed sequentially. So if the run test fails, you're not even going to execute all these steps. Everything is going to fail if any one of the stages fails. That's the real power of using a CI/CD. So with that, we conclude the part 1. I would encourage you all to take GitLab for a spin. The part 2 is where I'm planning to give a small demo of an app. So with that, if you have any questions or comments, please do let me know.
Wow, that was amazing, Hamsa. Thank you so much. I really think that was a lot of information, and also, you really presented everything so well. And nice of you to come up with a demo session. I'm sure that's going to be more helpful. Thank you so much. And so do we have, if at all we have any questions from participants, we can post them on our Q&A channel. And if you do not have any questions for now, we still have a part 2 session. So probably you could also collect some questions for Hamsa and come back, during our demo session. And I'm sure she's going to answer them. Awesome. So I would just give it a minute to see if anyone has any questions. Yeah, I'm seeing comments about, how amazing Hamsa's session was. Thank you so much. Definitely.
Thank you.
Oh, wow. So Gauri says she's really heard about all this, but never made much sense to her all these days. This was amazing. Thank you. Thank you, Gauri.
Appreciate that.
Awesome. So I think amazing. So we do not have any questions, right? Oh, yeah, I see someone post a question. Yes, my question is, there is so much going on with new technologies and tools coming up, but so much knowledge going around, I feel scared to start. How do I overcome this? Awesome. So she has a question around how she could overcome her fear and get started. Do you want to take this question, Hamsa?
Sure. So I would say like nowadays, like you have a lot of YouTube videos available on a bunch of different. Can you? Yeah.
I'm sorry. But I think Stephanie says she'd like to answer this question.
Nope. This is for the speaker. This is just behind the scenes.
Oh, okay. Sorry. Yeah, go ahead, Hamsa. I'm sorry.
Sure. No problem. So I would say just pick a small application that like you're comfortable with. Say for example, if you are comfortable with Java and Spring Boot, try to like build a CI/CD pipeline. Maybe you can use GitLab or any of these and try to build a small pipeline. Like start with baby steps. That's what that's what at least helped me to learn things. You don't have to build a complex project. It could be overwhelming, but the thing you have to what I learned is the concepts are going to remain the same. Like even if you're using Jenkins or GitHub or any of the other CI/CD pipeline, the underlying concepts are going to remain the same no matter what. So just pick up one particular technology, have a hands-on practice, because if you theoretically learn things, at least for me, I'll forget it after 3-4 days. If I hands-on do something and make a mistake, and even if it's a small thing, that's going to help me remember what I've learned. And of course, getting an experience to work in company is also a great opportunity to reiterate whatever you have learned. I hope I answered your question.
Yes, I think that was great, Hamsa. Thank you so much. And yeah, we have another question. So I think this person is from the automation team, and the team is planning to implement CI/CD to ensure test cases pass before we merge them to dev from dev to main branch. So they'd like to have more deep dive in writing the .yml file, but I guess we're going to do this during our demo. Am I right, Hamsa?
We won't go very deep dive into it, but I can link you to a documentation from GitLab. In case if you're writing it in GitLab YAML, they have an excellent documentation in order to write your own CI/CD pipeline file. It's just a matter of like understanding the keywords, which to use when. I can share the link with you. I can post the link with you here in the Slack channel, maybe after the call. Is that okay?
Oh yes, that'll be great, Hamsa.
Okay.
Awesome. That'll be great. Thank you so much. And so we're done with the Q&A. And here in the chat, I see Gauri has a question around how to get started with cloud computing. So do you have any thoughts, insights on the same?
I think WWC is a great forum for you to actually learn from other people. Personally, like I learned a lot from different speakers. I've attended 2-3 sessions in the past, and it's very useful. Maybe like if you want to go into any one of the specific technologies, just pick AWS, because that's where I started my career with. So I learned AWS, and like you can take up any of the free YouTube channels available, wherein that will help you to understand the terminology. So you will know like, okay, like these are some of the features which every cloud provider offers. And definitely like chatting with other people in the community is also a great way to learn like what are all some of the trending topics, because there are like a lot of different topics within the cloud itself, where if you want to specialize in machine learning or data science, that is also another next step where you can get things going.
Awesome. Thank you so much, Hamsa. I think that was a great presentation, great Q&A session. We had excellent questions today. Thank you so much, participants. Thank you so much, Hamsa. And yeah, folks who attended today's session, I'm sure you must be really excited about the demo session, which is a follow-up session. Please log on to wwcodecloud link and register, sign up for the upcoming session. So we'll have it scheduled sometime very soon. Thank you so much. Thank you so much, Hamsa, for your time. Thank you, participants, for your time. Have a great rest of your day. Thank you.
Thank you. Thank you all for attending today's session.
Thank you. Take care. Bye.
Bye.